Thank you, Mr. Chairman. Thank you all for incredible testimony. Spending 30 years in the information technology sector, I've learned one thing is if you're going to take a scientific approach to anything, you can't use your own bias, but you have to suspect bias. I mean, many times I've gone to dealing with cybersecurity issues, programming security on physical networks, and it doesn't work the way I thought it was supposed to work. Several times I went in to check myself and found out what I suspected was supposed to happen isn't what was happening. In other words, my own bias of I program it for this outcome, but the machine was actually giving me the proper outcome. The only reason I say that is if you're going to take a scientific approach, you have to check your own bias as well. So when I ask some questions here, don't interpret what I'm trying to say. We have to understand that we all have bias. And we also have to look are there occasions when the output isn't what we expected, but it is the right output? And the only reason I'm going down that, because I'm going to ask some questions just to try to help us get to where are we seeing the bias? And I'm not going into questioning or making a statement that yes, AI is perfect and it is working the way it should be, that there's anything wrong with the testimonies. I think as a community we have to come together and we realize that this is the future we're going to, and we have to get things right. And so I just wanted to say that if I ask questions, don't take it that I'm trying to question the validity of what you're telling me. I need to dig a little deeper in some of this. Ms. Henry-Nicke, as we're all concerned about potential bias in algorithms, we know from a scientific approach, humans have much more potential for bias than machines, if properly utilized and programmed. I think that's where we're getting. Ms. Williams said something in her testimony that just highlighted, I just kind of want to step through some things to see if we can really drive into where the issue exists. In her testimony, she was talking about home mortgage disclosures and showed that, and I believe, if I'm right, Ms. Williams, this was AI approving home mortgages, is that correct? And I think it was like only 81% of blacks were approved and 76% of Hispanics were approved. So my question, Dr. Henry-Nicke, is how do we know that those numbers weren't correct? In other words, was a 19% disapproval of black borrowers and 14% of Latinos outside of what would normally we see if it wasn't through through an algorithm?
It's difficult to answer that question without looking at the algorithms, but I'll tell you that it's not fair to assess what a proper outcome should be. The context matters.
Right.
And so if the market bears an average denial rate of 19%, then that's the market. And so if both groups, Hispanics, African Americans, and white borrowers are being denied at systematically similar rates, then that's an outcome that I don't think we can argue with. What's troublesome or concerning.
Move the microphone, yeah,
Sorry.
the very directional microphones here.
What is troublesome or concerning in that kind of example would be a model that's systematically denying minority borrowers, and having that be based on their race or predicted by their race. So
Right.
I think it's, and we said it all in the panel, looking squarely for computational technical solutions is part of the answer,
Right.
but it's not the complete answer. We need a systematic approach to making sure that we can understand, what's going on in these algorithmic applications, and also from there to monitor effects and, most importantly, processes.
And so when it comes to testing AI platforms, it's not just the algorithm. There's a whole lot of emphasis on the algorithm, which is a mathematical equation. That's one part of a four-part testing that we need to do. The appropriateness of the data, the quality of the data, the availability of the data. You also have cognitive input systems that have to be considered. If it's using facial identification for something, is that actually operating? So the reason I'm asking the questions is to say, are we focused on an algorithm when the problem may actually be in the data, or the appropriateness of the data if there is, and we just will make the assumption for this argument, that the output of the AI system is wrong. But I also think we do have to have empirical data to prove that the output is wrong and it's not in our own bias. And I'm not suggesting that that's what it is, but from a scientific approach, we have to do that. In a forensic way, if we're going to find out where the problem is we have to consider all that. And so if we have a second round, I'll have more questions. So, thank you. Thank you, Mr. Chairman. Unfortunately, we only have a few more minutes. I think we could all be here all day discussing this. So Ms. Williams said and Dr. Kearns said earlier has really been resonating. Not all bias is bad, which we agree. In fact, if we take kind of the model we've been talking about, loan applications, whether it's mortgage or not, the whole purpose of the AI platform is to be biased, right? That's the actual purpose, is to be biased, but what is the biasness that we want? We want those who are likely to pay a loan back, really, is what we're getting at. So I think I see where you're saying there is some bias that you want in there. What is the bias we want to eliminate is really the question, and that goes something Dr. Kearns said is, well, if we reprogram it to make sure more of one racial group gets more approval, then you may see a gender impacted. And so this is kind of a conundrum we're in until we figure out or define what biasness do we want in a particular system, but more importantly, what do we not want? When I look at it as what do we not want, if Mr. Budd and myself are identical, I know that we're identical in incomes because I know what he does for a living and that the law doesn't allow him to take any other income, right? But if he's Hispanic, I'm white, and the chairman is black, and we all have the same income, we all have the same assets, we all have basically the same biographical data, do we all get the same result, whether it's approval or disapproval? That's really what I think we're trying to get to. It isn't that, well, we weren't happy with the result that came out, and if we don't, we've got to go back and find out why, and that's where we're getting at. Mr. Ghani, if it exists, and since algorithms are a mathematical equation, really, I think part of the problem is when you get into machine learning and the algorithm begins to rewrite itself, how do we track it, right? So we verify the data is good. I think most of the problem we have is probably in the data and the appropriateness of the data. Let me see, not just in the raw data, but the appropriateness of the data. But if we do want to check the algorithms, is there a way of running what I would call in the network world an audit trail in the development of the algorithm, throughout the operation of the algorithm, and each phase of decision that's making in the actual coding, and is there a way to go back and do a forensic audit trail in these algorithms?
Yeah, absolutely, and I think that's the right approach. Is you can audit the data, and that's great, but then you're gonna. So I think the starting point is, you want to tell it what you want the system to achieve. Then you want to turn those into technical requirements for the system to see what to tell it to do. Then you want to confirm that it did what you told it to do. And then you want to test it and see, does it continue to do what it did yesterday, right? So that's when you ask sort of what should we ask a company to disclose. It's not the algorithm, it's not the code, it's not the data. It's this entire audit trail. And that's what we need to look at to figure out where it's happening.
An interesting aspect, and take it a step further, the difference between software and artificial intelligence is we expect software to give us the same result every time, right? That's not the case with artificial intelligence, correct? Because artificial intelligence is always looking for other data, and it may give us a different outcome the next day based on something that changed the day before. And it may rewrite itself to learn new things. And I think that's some of the challenge going forward is if you tell the machine that is not the right answer, it's going to look for a different answer in the future. I mean, this is stuff we wrote science fiction about just 10 years ago, right? So, when we code the algorithms themselves, can we actually program in the artificial intelligence platform to do systematic reports throughout the process?
Absolutely. I mean, that should be standard. That should be part of our training programs for people building these systems. That should be part of training for auditors who are doing compliance. Absolutely, that's the right approach.
And the last part is probably more a statement than a question. As in my opening statement, I talked about different analytical models. I think the one that concerns us the most is what I call the execution model. We have presentation of data, we have predictive analysis, we have prescriptive analysis that prescribes, okay, approve or don't approve. And we can do that, but yet there's a human element making the same decision. It's like the backup warning on my car that beeps and it says something's behind me. It doesn't stop the car. I still make the decision. But if you watch the Super Bowl, the smart talk, right, it's actually making the decisions. In this case, it's the machine making the decision of go, no go on the loan. It's executing on that. And I think until we get this fixed, we may need to look at, okay, is there an appeal process for that go, no go that a human element can go in and work? So thank you, Mr. Chairman. It sounds like our warning bell's going off and my time has expired.